Hello everyone, I'm Akshay. First of all, I would like to sincerely thank my professor Kadi for giving me this opportunity to present my project. In this project, I have implemented and compared two algorithms for solving closest pair of points problem. The brute force algorithm and the divide and conquer algorithm. The main objective is to observe the empirical computation complexity of both methods and compare how closely the measured results match their theoretical time complexities. So let's begin by looking at the setup and execution of my program. First, I implemented both algorithms in Python using Jupyter Notebook. The first step is importing all the required libraries like math, random, time, and matplot libraries. This handles distance calculations, random input generations, and timings and graph plotting. Before running large datasets, I have been compiled and executed the both algorithms on the small datasets containing just few points to verify the algorithms works, identifies the closest pairs, and compute the right distance. From the next, I have been implemented the brute force algorithm that calculates the distance between each pair of points and keep track of the minimum distance found. Although it's simple and easy to understand, this method performs n square comparisons, which makes it insufficient for the large input sizes. From the next, I have been implemented the divide and conquer algorithm. The divide and conquer algorithm improves efficiencies by sorting the odd points and coordinates, dividing them into a half and solving each half recursive, checking only the points closely to the divided lines. It time complexity was n log n, which significantly reduced my runtime compared to the previous. But the next, I am measuring the runtime for the both algorithms. The runtime is measured using the time performance counter before and after each algorithm execution. Each input size runs 10 times, and the average runtime is calculated as the total number of divided by 10. This helps to eliminate the random variations and give stable performance measurements. So for the input generation, here you can see I had been run the code and we get the output. I generated a random and unique XY coordinate pairs using the random integer function. The same dataset has been used for the both algorithms to ensure fairness in the comparisons. This experiment covers 10 input sizes ranging over 10,000 to 50,000 points. As you can see, the algorithm 1 and algorithm 2 results has been for the each node and the points. For computing the C1 and C2, I generated the random using the empirical runtimes. I have computed the constant C1, C2 to link theory with the real results. The theoretical models are n square for the algorithm 1 and n log n for the algorithm 2. Dividing the empirical runtime by the theoretical values gives the each constant, showing how well the actual performance fits the expected components. Here you can see the constant C1 value for the algorithm 1 and constant C value for algorithm 2. For generating the tables, two tables summarizes the experimental data. As you can see, the tables from the two algorithms where have been inserted column includes the n value and the theoretical runtime and empirical runtime ratio and the predictor runtime. This table clearly shows the quadratic growth of algorithm 1 and the linear growth of algorithm 2, confirming the theoretical trends. So while coming to generating the graphs, the three graphs have been plotted from these results, which is empirical runtime comparisons between algorithm 1 and algorithm 2 directly, and the second graph goes for algorithm 1 for the empirical versus predicted, validates the n square patterns, and for the third graph, where it goes for the empirical and predicted, confirms n log n behavior. So the divide and conquer curves increases much more slowly and clearly and demonstrating the better scalabilities. So while generating and seeing this all, the project confirms that that both algorithms were implemented correctly and produce the consistent results. The brute force method grows quadratically with the input size, while the divide and conquer algorithm achieves far better performance and match its theoretical complexity. Therefore, based on the both empirical and theoretical analysis, the divide and conquer algorithm performs the best. Thank you. Thank you so much.